All right, here we are on the Mod 6 Day 12 worksheet, and we're going to be starting with some similar triangle proofs. After we prove that the triangles are similar, we can then set up a proportion and solve for x for each one, if they are similar. If they're not similar, we can't do that. So here we go. First one, do you see these little parallel line marks right here? Whenever we have parallel lines, we know that that means that we've got some angles that are congruent. So in this case, those two pink ones are corresponding angles, or you could even do these two sides as corresponding angles, but we just need two angles that are congruent in order to use AA similarity theorem. And notice we also have a reflexive angle here. So you can choose any of the two. Here we go. I'm going to say angle C is congruent to itself by the reflexive property. And then I'm going to say that angle A is congruent to angle CBD parallel lines mean that corresponding angles are equal. And so since we have two angles, we can finally say that triangle EAC is similar to triangle DBC by AA similarity theorem. So there's our full proof with statements and reasons using AA similarity theorem. Now we can go and solve for the x. So let's set it up as small is to big as small is to big. Notice that that second big is going to be a combination of 3 plus 5 or a side length of 8. Okay, so we're going to say x is to 8, there's my small is to big, as x is to 8. And then we cross multiply, we get 8x equals 40. And so we get 5. So let me just show you one more time how we set up that proportion. Small is to big as small is to whole side, 5 plus 3 is 8. And so we said x is to 8 as 5 is to 8. And so x is just 5. All right, next one, let's go see if we have two angles, which is enough. It's our simplest one. And I notice that I have angle M congruent to itself, another reflexive property. And then I've also got these angles here that are just given. So previously we had parallel lines. We had to know that the corresponding angles are equal. These two are just given in the image. So angle MNQ is congruent to angle MOP, and that's given. Now I have my two angles. Here's the other one up here that we just said. And so I can say that triangle MNQ is similar to triangle MOP by AA similarity theorem. Now that I've proven similar, I can go ahead and do the side length proportions. So let's say on this one, I might look at it like small is to big as small is to big. And so on the side, 6 plus 5 is 11. On the left side, it's an x plus 3. So I would set this up as x over x plus 3, small is to big on the left, is equal to small is to big on the right. And I'd get 11x equals 6 times the quantity x plus 3, or 11x equals 6x plus 18. And we get 5x equals 18. Divide by 5, divide by 5. And I'm getting that x is approximately, grab that calculator, 18 divided by 5. Oh, I don't even need the approximation here. X is equal to 3.6. And then this one was x equals 5. All right, pause the video and try this last one on your own and see how you do. Okay, notice that we have, again, two angles. Why? Because it tells me right here that WZ is parallel to VY. And if I have parallel lines, then I have corresponding angles that are equal. And notice that up here, I have another reflexive angle. So you can use the two corresponding angles, or you can use the reflexive angle and a corresponding angle. It's up to you. I'm going to say angle X is congruent to itself by the reflexive property. And then I'm going to say angle XWZ is congruent to angle XVY. And that's by parallel lines, corresponding angles are equal. Now I have my two angles. Now I have enough for similarity. Triangle XWZ is similar to triangle XVY by a similarity theorem. Now I can set up my proportion and solve. Small is to big as small is to big. I'd go x is to x plus 2 as 7 is to 10. Cross multiply. I'm going to get 10x equals 7x plus 14 minus 7x from both sides. I get 3x equals 14. Divide by 3. Grabbing the calculator. 14 divided by 3 is approximately 4.67, or if you rounded, if you did the repeat bar, you'd say equals 4.6 repeating. Either of those work. All right, how are you doing on setting up the proportions? How are you doing on the proofs? There's going to be 2 of those on the upcoming test. All right, next one is a reminder of first semester radicals and exponent rules. Let's see how you do. First part's already fine, 3x to the 4th y. We're going to save this for later. Remember, there is a little invisible 1 here with this y, because the back part has a squared. So that means you've got 5x to the 3rd y to the 5th, not only one time, but 5x to the 3rd y to the 5th 2 times. It's being squared, so that's, stretch that out twice. That's called expanded form. And then all these big numbers in the front, 3, 5, and 5 are going to multiply, those big coefficients. So 3 times 5 is 15. 15 times 5, you got it, that's 75. Then I've got x to the 4th, x to the 3rd, x to the 3rd, and those exponents are all going to be adding. You got it. 4 plus 3 is 7. 7 plus 3 is 10. So that becomes x to the 10th. Now remember, there's a little tiny y to the 1 power, and then the 5th power, and then the 5th power. So 5 plus 5 is 10 plus 1 is 11. There's my total simplified answer, where I multiplied all of the big exponents, and then I added the powers for all of the same bases. Okay, moving on, let's look at things piece by piece here. For example, I've got a 6 over 24. If that was just a regular fraction, I'd say 6 goes into 6 once. 6 goes into 24 4 times. 6 24ths becomes 1/4. Next, I've got x to the negative 3, and then x to the 5th in the denominator. So the subtract rule comes into play here, where I'm going to go negative 3 minus 5. We subtract the number in the denominator. And same for the y's, where you could say y to the 17th minus the 8th. So the 17 minuses the 8 below it. So whatever's in the numerator for the power is going to subtract. That's the subtract rule, the number in the denominator's power. So final answer, it's going to become x to the negative 8 y to the 9th over 4, and then that x to the negative 8th, that negative exponent, needs to be moved downstairs. It's repeatedly dividing for my final answer. Do you remember these from last semester? How'd you do? All right, next one, we're going to break down 52. What times what times what equals 52? Well, I know that 2 can go in 2 times 26. And then x to the 5th, if I stretch that out, that means there's 5 x's. And then y to the 12th, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you're like, that's too many y's to write. So then don't write them all out. Just do the divide thing. If you're like, what's the divide thing? Never mind. Write them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we are looking for pairs. Notice that the 26 can still be broken down. 26 could be 2 times 13 as well. So now that I broke that 52 into 2 times 2 times 13, what do you think for pairs? Notice there's a pairs of 2. A 2 can come out. An x, another x. That's an x squared that can come out. Y. That's 1, 2, 3, 4, 5, 6. So that's y to the 6. They all come out. So what's left inside? That's got to stay in, and their multiplying is 13 times x. And there she is, my fully simplified radical. What do you think? Don't you love these? Okay, next has a 5 on top. Break down that 18. 18 is 9 times 2, which is 3 times 3 times 2. Take a minute to look at that and see if that makes sense for you. 75 is 5 times 5, there's 25, times 3. Okay, take a pair of 3's out. That 3 that comes out is going to be multiplying with the 5, and then there's a root 2. On the bottom, a pair of 5's, a 5 comes out, and then there's a root 3 left in the bottom. So notice that these 5's could cancel out, and I'm left with 3 root 2 over 3, but you guys know that we can't leave a root 3 in the denominator, so you need to multiply or rationalize that denominator. The purpose of multiplying by root 3 over root 3 is so that the denominator of a 3 just comes out. And then in the numerator, it's 3 times root 2, root 3, which is going to become root 6. What do you think? There you go. That one's finally done. All right, midpoint. This is to find the middle of these 2 points without having to graph them, without having to count a slope, halfway, or anything like that. It's using a little formula. It's where we average the x's and the y's together. So what do I mean by that? I mean, you're going to take the first x and the second x, and then you're going to divide it by 2. So that's 15 plus 9 divided by 2. And then you're going to take the back y's, and you're going to do negative 8 plus 14, also divided by 2. So that's going to become, you got it. Hang on. I think I want to write the formula for you up here and then write the work here. This is going to become a coordinate pair of the midpoint, and this is going to be negative 8 plus 14 over 2. And so 15 plus 9, do you see how that becomes 24 over 2? What is 24 over 2? 12. Negative 8 plus 14 becomes 6 over 2. So final answer, 12, 3 is my midpoint. And let's write the formula in right here. Y1 plus y2 over 2. x1 plus x2 over 2, y1 plus y2 over 2. There it is. Altogether, the midpoint formula where you average the x's and you average the y's. Okay, for reals, pause the video right now and try it. Right now. I noticed you didn't pause it. Now really for sure, pause it. Try it. Okay, let's see how you did. So x plus x, 22 plus negative 4, and negative 1 plus negative 11. So 22 plus negative 4, that's just going to be 18. grab your calculator, double check that. And the -1 and -11, that's just going to be -12. So 18 over 2 is 9. -12 over 2 is -6. There's my midpoint. Pause the video if you didn't last time. Do it now. 9 plus -5 over 2. 12 plus -4. That's going to be 4 over 2. That's going to be 8 over 2. 2, 4. All right, last but not least on this page, let's do one proof. Start with the givens. The first given says that FA is parallel to TS and C is the midpoint of FS. After we write these first two givens, I want you to go mark the picture. If C is the midpoint of FS, then that means I now have two baby sides that are congruent. I have that FC is congruent to what? You got it, SC. That's by definition of midpoint. Okay, what else do I have from the other given? I was told that these two lines, FA and TS, are parallel. And you guys know that if I give you parallel lines, it's definitely an angle relationship. Do you want to do F and S? Or do you want to do A and T? Both of those are alternate interior angles that are equal. So I guess I'll just do F and S. Angle F is congruent to angle S by parallel lines mean alternate interior angles are equal. Okay, what do you want to use? The other alternate interior angles, or you want to be a little crazy and you want to go use the vertical angles? This guy right here. Angle FCA is congruent to angle SCT by vertical angle theorem, or vertical angles are equal. Now I'm trying to prove that these two pieces are equal, so I'm going to do this by way of triangle congruency. And this whole time I'm doing this, I'm thinking, do I have enough for congruency? And I do. I've now got an angle, a side, and a vertical angle. So I can now state that triangle FCA is congruent to triangle SCT by angle, side, angle. And finally, I go up to do my proof statement. And I say that AC is congruent to TC. Do you remember what it's by? You got it, CPCTC. All right, that's the front of the worksheet. How'd you do?